Okay, hello everybody. I'm just going to do a little video today on Surds. We're going to recap Surds, go over everything that we should have learnt on Surds, and hopefully this will help you get to grips with it a little more. Okay, so a surd is a square root. That's all a surd is. It's sometimes called a root or it's called a surd. It is a square root, okay? And the idea of a surd is so that instead of writing a really long decimal, we could write it as a surd and then it's easier to use. So for example, root 2, if we were going to write root 2 in our calculator and press equals, it would be 1.414 blah 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 blah. But if we were going to use that in a calculation, it would be much easier for us to use root 2 than it would for us to use 1.412 blah 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 blah. Okay, that is the point of a surd. Let's turn the light on so you can see a bit better. Okay, lovely. So we need to be able to do all the calculations. So we need to be able to multiply them, we need to be able to divide them, add, subtract, expand and rationalize. Oh, and simplify, okay? So we're going to start off with multiplying and dividing, which I'm hoping will be very straightforward for you. So here we go. I'm going to write the rules. In fact, I'm going to write the rules on a separate sheet of paper alongside the piece of paper we're working from here, okay, so that you could get these rules down in your books as key points as well, okay, as well as these examples. Use this video, come back to this video, you don't have to get it all down now, but we'll write the rules as we go along. Okay, so if I have got root A and I times it right by root B, that is the same as doing the square root of A times B, or the square root of AB. Okay, so for example, if we had root 3 times root 5, that is root 15. Okay, similarly, root 10 times root 2 is root 20. Hopefully that makes sense. Okay, same with dividing. If we divide root A divided by root B is the same as root A over B, A divided by B. So if we had root 10 divided by root 2, that would be root 5. Okay, multiplying and dividing, fairly straightforward. Okay, I want you to think about this other rule then. What about if we had root 2 times root 2? Well, if I use the same rules that I've just talked about, that means that root 2 times root 2 is the square root of 2 times 2, which is 4. But 4, obviously, hopefully, is a square number. So the square root of 4 is just 2. Okay, so then if we had root 5 times root 5, that would be root 25, and the square root of 25 is 5. So if your numbers underneath the root are the same, that means that when you multiply them, you just get that number. So if we had root A times root A, we would get just A. Okay, now that's going to be important when we are simplifying. Hopefully that makes all load of sense. Okay, let's look at simplifying then. Let's look at that over here. So simplifying is, oh, actually, before we go on to that, hang on, let's just do this first of all. Let's do 3 root 2 times 4 root 5. Let's look at those ones, okay. Now, when you're thinking about surds, I like to think of them a bit like x's, a bit like algebra. So this is like having 3x times 4y, if you like. Okay, so do your numbers first and then do your roots. So 3 times 4 is 12, and then root 2 times root 5 is root 10. So the answer is 12 root 10. Okay, now similarly, if we had 5 root 5 times 2 root 5, again, think of it the same, but except for this time, these roots, the numbers under our roots are the same. Okay, so it would be like 5x times 2x. Okay, again, just do your numbers, don't rush it, just think clearly, do it logically, and you'll be fine. So let's do our numbers first. So 5 times 2 makes 10, and then I'm timesing it by root 5 times root 5. Root 5 times root 5 is just 5, because we've just learnt that up here. So then this becomes 10 times 5, which is 50. Okay, the reason this works is because 5 root 5 just means 5 times root 5. Just like 5x means 5 times x, this just means 5 times root 5. This just means 2 times root 5, and if we're going to times them together, if we're going to times them together, it doesn't matter what order we times them in. So we can do our two numbers first, and then our two numbers first, and then our two roots, okay? And the answer becomes 50. Okay, hopefully that makes sense. Right, then we're going to go on to simplifying. Now, simplifying is, where you have the number under the surd is the smallest number possible. Okay, so we're going to do it by looking at an example. Let's look at root 75. Okay, so in order to simplify this, we're trying to end with it being something like 3 root 2 or 7 root 5 or 9 root 3. Okay, we want the number underneath the surd to be the smallest possible. So the way I'm going to do it is a factor tree. Now I want you to do it like a factor tree, like you would do for any number. So we're taking the number 75 and we're thinking of prime numbers that go into 75. So 5 is the most obvious, but because we are talking about root 75, sorry, we need to take out root 5. Okay, how many 5s go into 75 is 15, hopefully, and we're going to call that root 15. Okay, we're then going to work on that. That we can circle because that is prime. If we take out a factor from 15, we can take out 5 again, and that goes 3 times. Okay, that then tells us that root 75 is root 5 times root 5 times root 3. Okay, what is root 5 times root 5? Well, if the numbers underneath the root are the same, we can use this rule. So that means that that is just 5, and I'm timesing it by root 3, so I can write that more simply as 5 root 3. If you don't believe me, let's just put it into our calculator. Can we see that all okay? Okay, let's put in root 75 and press equals. Now before it goes to a decimal, it will write it as a root, and that is 5 root 3, which is what we got here. Okay, hopefully that makes sense. That is simplifying. So when we simplify, we use a factor tree. Okay, hopefully that's all okay. Right, we are going to go on to adding and subtracting. Now, while we're doing adding and subtracting, I want you to remember what I said about thinking of surds as like x's. Okay, so here we go with our first example. If I've got 4 root 3 and I add 2 root 3. Think of it like x's, 4x plus 2x. Well, 4x plus 2x makes 6x, so 4 root 3 plus 2 root 3 makes 6 root 3. The roots don't change, just the number in front stay the same. Just the number in front add together. Okay, similarly with subtracting, if you had 7 root 2, take away root 2. That's like saying I've got 7x, take away 1x. So I've got 7 root 2, take away root 2, so I have got 6 root 2. Hopefully that makes sense. That is adding and subtracting. Now, obviously that becomes more complicated if, for example, you had something like this. Okay, 4 root 5 plus 6 root 3. Now here, I said to call these like x's. So that would be 4x, and that would be 6y, because the root is different. Can we add 4x and 6y together? No, we can't. So we cannot simplify that anymore. The answer to that is just 4 root 5 plus 6 root 3. It does not simplify any further than that. And again, if you don't believe me, we can do them on the calculator. So let's do the first one to start with. So we had 4 root 3. If you're typing on the calculator, make sure you push your right hand arrow to get out of the surd. Okay, oh, I don't know if you can see me, sorry. So 4 root 3 plus 2 root 3 makes 6 root 3. Well, happy days. That's what we put up there. Okay, now we're trying to do this other one, which was 4 root 5 plus 6 root 3. So 4 root 5, arrow across, plus 6 root 3. That doesn't simplify. That is as simple as it goes. Okay, so in order to add the surds, what we've just worked out, in order to add or subtract the surds, the number underneath the surd has to be the same. Okay, what happens then if that's not true and it does want us to simplify it? So what happens if we had something like, let's get one that works, root 80 plus 7 root 5. Okay, so what I've just been talking to you about, it would appear that we cannot add these two surds because this number and this number are different. However, here, the number underneath our surds were prime, which means that they cannot be simplified further. However, here I have got a root 80. Now 80 can probably be simplified. So let's see. So when you've been given something like this, you can try, first of all, to simplify any surd you can. Now we're not going to be able to simplify this one because this one is already prime. Let's try and simplify this one. So I'm going to do my factor tree as normal. So I can take out 2 and 40. I can take out 2 and 20. I can take out 2 and 10. And 2 and 5. Okay, so what that tells me is that root 80 is root 2 times root 2 times root 2 times root 2 times root 5. Now, from earlier, root 2 times root 2 is just 2. Root 2 times root 2 is 2, and we've still got the root 5. So that means that root 80 is 4 root 5. Okay, let's come back up to our question. We've got root 80, which is 4 root 5, plus 7 root 5. Add those two together, gives you 11 root 5. Okay, and the same with subtracting. So let's just do a little subtracting example. What happens if we had root 72 take away root 8. Okay, so at the moment we can't subtract them because the numbers underneath the roots are not the same. We're going to do a simplifying factor tree and see if we can get them to work. So that is root 2 and root 36, root 2, root 18, root 2, root 9, root 3 and root 3. Here's my factor tree. Okay, that means that root 72 is root 2 times root 2 times root 2 times root 3 times root 3. From this rule again, root 2 times root 2 is 2. We've still got him and we can't pair him up with anyone, so he's on his own. And then we've got root 3 times root 3 is just 3. So we've got 2 times root 2 times 3. Let's tidy our numbers up. 2 times 3 is 6. So I've got 6 times root 2, which makes 6 root 2. Okay, let's look at root 8. Take him over here. We can't now add the 6 root 2 and the root 8 together because the 8 underneath the surd doesn't help. Okay, so hopefully when we simplify this, we'll end up with a 2 under the root. If we don't, that just means we can't simplify it any further. Okay, we can't add them together. Don't add them, can't subtract them. Okay, but let's see what happens. So root 8, we can take out a root 2 and a root 4, a root 2 and a root 2. That means root 8 is root 2 times root 2 times root 2. Root 2 times root 2 is 2 times root 2 is 2 root 2. Let's go back to our original question. We have root 72, which is 6 root 2. Take away root 8, which is 2 root 2. We take them away. 6x take away 2x makes 4 root 2. That is subtracting. Okay, so with adding and subtracting, our key point is that the number underneath the surds must be the same. Okay, right, I'm going to stop the video there and I'm going to come back to expanding brackets with surds and then rationalising with surds.